All right. So today we are going to be adding at the end of the class period to our essential question. Remember, our essential question for today is, how do I find the area of different 3D shapes? All right. Yesterday, I pulled some words out: find, means solve, evaluate, answer. Area is the inside of a 2D shape, and 2D is a flat shape. All right. Looking at our first activity for today. Zoom in a little bit. So it says, you may recall that the term area tells us something about the number of squares inside a two-dimensional shape. Here are 4 drawings, and everyone has their pencils down. You don't need to be writing, I need you listening. Okay? I'll give you enough time. Here are 4 drawings that each show squares inside a shape. Select all. That means that there might be more than one answer. Drawings whose squares could be used to find the area of the shape. Be prepared to explain your reasoning. So let's say you pick A or B or C or D. Whichever one you pick, or whichever ones you pick, next to it I want you to just jot down a little of why you picked it. Doesn't need to be a full sentence, just needs to be a couple of words as to why you picked that shape. Then, number 2 says, write a definition of area that includes all the information that you think is important. So right now, we know area as inside of a 2D shape, right? So now, after picking A, B, C, D, you're going to add some information to your definition. Because you should learn that it's more than just inside the 2D shape. Does that make sense? Based off of why you're not picking A or B or C or D. All right, so you're going to get 5 minutes of think time and work time, and then we're going to go over 1 and 2 together. Okay, does that make sense? All right, so 5 minutes, this is quiet work time, go. You should be writing and doing nothing else. Writing only. All right, go ahead, put your pencils down. All right, so what we're gonna do is you're gonna stand up with whichever letter that you picked or picks. So if you picked A, stand up for me. Have a seat. If you picked B, stand up for me. Okay. If you picked C, stand up for me. And if you picked D, stand up for me. All right, have a seat. So let's go ahead and talk about B because nobody picked B. So why did nobody pick B? Like, what was your reasoning for not picking B? Luke?
Because I said because you know how there were big squares and there was little squares, so I was saying because they're not even squares.
All right, so essentially the square units have to be exactly the same size?
Yes.
Okay.
But it has to be the size, but if they look like the triangles, they're probably cut in half because it's not a full square.
Okay. All right. And please make these notes as I'm making them next to each one, A, B, C, and D, just so that you have the knowledge of why it didn't work. All right. So that's B. Now we had two people pick C. So Claire, what was your reasoning for picking C?
Because if you flip that square over, it would make a whole like square.
So if I take this and just slide it up,
Mhm.
okay? All right, Justice, what was your reason for picking C? Like, what'd you write next to C as to why you picked it? Huh? What was your reason, babe? I'm curious. Claire told me hers, and I wanted to know why you picked it. Yeah, I need you to explain your thinking. That's all I'm asking you to do, okay? Justice, I will be calling on you again today, and I need you to explain your thinking. Do you understand? It's not a right or a wrong or anything. It's just I want to know what you're thinking. All right, so why does C not work? Anybody tell me why C does not work? Charlotte.
It doesn't work because the squares are tilted.
That's not necessarily the reason it doesn't work. Jackson?
Because one of the squares are slanting into another square.
So this part is overlapping. All right, so overlapping. All right, and what else do you see? So this part right here overlaps, right? But what else do you see that's different from all the other shapes? Anna?
There's a section that doesn't get covered up.
So there's a gap, right? Like there's a hole essentially. So overlapping and gapping. All right. So that is why C does not work, because you can't just overlap some shapes, right? Now, we had a lot of people pick A, and we had a lot of people pick D. So let's hear some reasoning from those of you who picked A as to why you picked A. Bradley.
Well, for me, I said like for A, like since like all the square, like most of the squares are like the same size, they're kind of all equal, so it's gonna be easier to add them up. And I would say the same thing for D too.
Okay, so you said same size was important.
And also said the same thing for D.
Okay, so same size as well. All right. Why else does A work? Shelby. It what? That doesn't matter. You can have teeny tiny little baby squares as long as they're the same size, right? There's another reason why this works. Jackson?
Because with A, you would, how we say, never use the slanted parts.
Okay.
You can actually cut off the slanted parts evenly without, and still have a number without it being like 3.5 or something.
Boy, we can't get rid of that piece, right? We can cut that piece off, but what do we have to do with that piece in order to find the total area of that?
We have to add it back.
Where?
We have, wait.
So I cut this piece off. Where am I adding it? Where am I gonna? It's not in your notebook, baby. I cut this piece off, so this piece is gone. Where does that piece fit on my whole shape, though? Look, where does it fit?
Oh, it fits on your corner right there.
Right. So I just put it there, and then I make a rectangle.
Yeah.
Okay?
Oh,
That is called decomposing and rearranging to make a shape that we know, correct? We know how to find the area of a square, right? All right, so it's the same size,
and not overlapping too.
right? It doesn't overlap. We can cut apart and rearrange. All right. So isn't that exactly the same thing we could do for D?
Yeah.
Yes.
So it's the exact same reasoning. So same size. We can cut apart. And rearrange. So then with our definition, the first part we know, so it's inside of a 2D shape. But what else did we add to our knowledge to just with this activity? Claire?
Area equals length times width.
No, we already know that. What did we learn from our activity just now? Guys, finding the area is not length times width. That is not the only formula we talked about. That is why some of you guys got it wrong yesterday. That is not area. That is a formula. We learned formulas yesterday. Luke.
So we learned that the squares must be the same size in order to cover up the whole shape, and that
Hold on. One at a time. Must be the same.
size.
All right, I'm going to call on somebody else. All right, so it must be the same size. What else did we learn? We wrote it up there. So the two that don't work, obviously we're not going to put that. But what did we learn about the two that do work? That's what I'm asking for. I'm asking for that information. I'm also asking you to maybe add some of this information in right there. I need some new friends. I'm tired of talking to the same ones. Yes,
The units can't overlap.
okay. Alright, what else? Ava.
We can rearrange.
So decomposing and rearranging. And there's one more. One more. So we've talked about no overlapping, same size, decomposing, rearranging, and what? Only one thing left.
No gapping.
Yes, so no gaps. All right, please make sure you have this information down. When you do, stand up. Alright, so what else now can we add to area? So we talked about the inside of a 2D shape, but what else have we learned? What else have we learned? I meet new friends, I'm not gonna meet the one of you. So all you have to do is reread what we just wrote. Give me one thing that we learned. Anna.
They have to be the same size.
So they have to have same size units. What else did we just learn? Ava.
No gapping.
No gaps. Alright, what else did we learn? What was that?
They can't overlap each other.
Huh?
They can't overlap each other.
No overlapping. Alright, anything else new that we learned? Charlotte.
We learned decomposing.
Okay. Alright, what else? What else did we learn? I've already talked to those friends. Yes. Rearranging. And then there's one more thing that we learned yesterday that has to do with our answer. What must we do when we're finding area? What must we do to our answer? Okay? Not cubed. How many numbers are you multiplying? So it's gotta be squared. Alright. So we're good with our assumption question. Do we want to add anything else? Feel like we're good with it now? Alright, let's slide over to the next part of our lesson today. So it says, actually, no, we'll read this part. Your teacher will give you one square and some small, medium, and large right triangles. Alright, what I need you to do right now, take your paper, your notebook, and your pencil, and I want you to close your notebook and slide it to the edge of your table. I also need you to take your pen and slide it to the edge of your table. So there should really be nothing in the middle of your table except for that little bag that has triangles and squares in it. Alright? Now, how many of you guys are what they call a kid at heart? Like you want to be a young adult, but really you're still a kid inside. Okay, that is every single one of us when something new is put in front of us. Whether it's a piece of paper or whether it's why are you touching the bag? Whether it's a piece of paper or it's triangles and squares and whatever. So, to avoid the playing while the lesson is going on, you're going to get 2 minutes of playtime. What that means is there's no talking. You are not talking to your neighbors, your friends at your table, but you are manipulating these shapes. You're feeling them, you're not throwing them, you're not hurting anybody with them, but you're just moving them around and you're playing with them. All right, get it out of your system in the next 2 minutes. If you talk, I take a minute away. If I have to tell you to stop talking 2 times, we put them away, and I'll be the one who does all the modeling, which I don't want to. All right? Are you allowed to talk?
No.
Why are you flicking stuff at me? I will come across this table and whoop. No, I'm just kidding. No, so no talking, just manipulating. Go. No talking. All right, so do me a favor and put the shapes in the middle of your table. You don't have to put them back in the bag, just put them in the middle of your table. Open up your notebook. All right, so the last part of that we did not read while you guys were excited to play with your new math manipulatives was the area of the square is 1 square unit. So I want you to kind of separate your square from the rest of the shapes. All right, so this square is 1 square unit. All right, number 1, it says, notice that you can put together 2 small triangles to make a square. What is the area of the square composed of 2 small triangles? Be prepared to explain your reasoning. So if we take our 2 smallest triangles and you put them together, you make a square. Right? We agree?
Yes, ma'am.
How do we know if the square that we originally started with, which is 1 square unit, we know that because it tells us that. But how do we know that the 2 triangles put together is also 1 square unit? How do we know? Okay. So they're even, they're equal, right? And a really good way to see is to take your 2 triangles and put them on top of the original square and see, are they even? And they are, correct? The bottom one is not bigger or smaller than the top one. So we know that it is 1 square unit because the one with 2 triangles, you said is even? Okay. Is even. What's a math term for even? Equal. Oops, I can spell that. Equal to, bless you, the original square. All right, give me a thumbs up when you have that written down. Thumbs up when you have this written down. Bless you. You should not be touching anything right now. All right. So for number 2, don't touch anything yet. It says use your shapes to create a new shape with an area of 1 square unit that is not a square. All right, let me read that again. Pencils are down. Listen. Use your shapes to create a new shape with an area of 1 square unit that is not a square. All right, you have 1 minute to work with your partners and get a new shape. Go.
Yeah, but that's not a square. It's 1 square. Each is half.
No. What does it say?
That would be
It's
like
gotta equal 1 square unit. Is that equal? Which one is it? By the way, it says that it's not a square. So you can't do that. So you're using something, you're not using anything except for this, because we just realized that these two is one of those. So make another shape. No, baby. Because if you put these together, you're gonna end up with not 1 square unit. This is 1 square unit. You cannot make another square, you must use those 2 shapes. Where's your shape? Guys, you should not be touching the big giant triangles, and you should not be touching the 1-piece parallelogram. You are making 1 square unit. Stop making this so hard. We just made a square unit, right? With what 2 shapes?
Triangle.
Triangles. So what 2 shapes should you probably be using to make a new shape? So everything else here, I'm gonna lose it. It's gonna happen. Stop what you're doing, because all you're doing is playing. Hence the reason I gave you playtime, right? So if I have to tell people as I'm walking around again to stop making 18 shapes, we're gonna put it all away and I will model up here. The first shape that you can make, you take 2 triangles, you put them like this. You make a triangle. That's 1. Draw it on your piece of paper. The next shape that you can make is a parallelogram. Draw it on your piece of paper. Another shape that you can make. How was it? It's one of those. Take a picture of it. Okay. So those are the two shapes that you can make. They both equal 1 square unit because you made it with the two original pieces that make 1 square unit. Do you see the connection? So these two pieces equal this. Oh, goodness gracious. These two pieces do not equal this, does it? It is not even remotely close. These three pieces do not equal this, does it? So pay attention to what it's asking you. Do not lose the ability to manipulate these shapes or whatever you want to call them because it's going to make this lesson a lot easier. Also, don't try to be rocket science. Keep it simple. I'm not asking for rocket science today. Maybe tomorrow, but not today.
Wait, what?
All right, number 3. It says, excuse me, use your shapes to create a new shape with an area of 2 square units. So again, our original square unit is our square. So now you are essentially trying to make a shape that equals 2 square units. When you have that shape, stand up. I'm going to set the timer for a minute, but we should be able to get it before that minute.
Nobody cares about how close you're trying to make it. Yeah, but we don't keep it that way.
How about the
All right, have a seat. Now, this was one that was created. How many of you guys created a rectangle? Perfect. All right, this was another one that was created. How many of you guys took one square and 2 triangles and you put them on the outside and you created a trapezoid? All right, so let's go ahead. We're going to draw those two. So we have our square and our 2 triangles. We have our square in the middle and a triangle on the outside. I don't have any triangles. May I borrow 2 of your triangles real quick? All right, what about this shape? Stop with the noises, please. So what about that shape? Yes, you can. Because what does it have to equal? 2 square units. So 2 triangles equal 1 square, right? So why can't we use 4 triangles? What?
Because
There is no, that works.
what?
That works. It works because, guys, what's half plus half plus half plus half?
2.
2. What are we trying to figure out? 2 square units. All right, so let's draw this one on there. And And then this one, which is a little bit more crazy for me to try and figure out. So what about that one? It doesn't matter. Why doesn't it matter? What was the only criteria that I gave you guys? It had to be what? 2 square units. Well, this one you guys already made, right? You already made a parallelogram. That we drew a parallelogram for the question number 2. So now we take a parallelogram and 2 triangles. How many? What's our total square unit?
2.
2. All right. So this one is weird. Alright, so those are the shapes that you can create when talking about 2 square units. Thank you guys. Alright, let's go ahead and flip this over. Listen. I kind of gave you the answers for number 4, so we're going to skip that one. All right. Number 5, it says, use your shapes to create a new shape with an area of 4 square units. 4 square units. So hold on, because we're going to have to do this when we come back from lunch, but I want you guys to understand. Hands off your shapes right now. Use 2 and 3 to help you with question 5. Why would we use 2 and 3 to help us? Bradley?
You can just kind of like go up with that and then add to that.
Perfect. All right, so again, I want you for the next minute to look at 2 and 3. Don't touch your shapes, but I want you to talk to your group members and kind of talk about how or what shape you think you're going to try to create that equals 4 square units.
Do you want us to use both of them, or is it option?
You have to come up with 4 square units.
Okay, so it should be an option, or do we have to use 2, or like any from 2 and then any from?
It has to be 4 square units.
Okay, so
I say we just double this.
no. Oh, come on.
Why?
What
do you like? I've been doing what you want. You want to get rid of
All right, go ahead, line up, y'all.
Oh, we got all
Line up. Hey, look, are you still having any problems with your keyboard? Yes. Okay, take your iPad, take it to Miss Brody. She's gonna send it in, get fixed, and give you a new iPad. So just go straight to Miss Brody on your way to lunch, and then come to lunch.